Hello everyone. In this video, we briefly explain the paper Multimodal Cross-Domain Few-Shot Learning for Egocentric Action Recognition. We address a novel cross-domain few-shot learning task, CD-FSL, with multimodal input and unlabeled target data for egocentric action recognition. Recently, several large-scale egocentric datasets, such as Ego4D or Epic Kitchens, have been proposed to investigate a variety of tasks, especially in a daily life domain. On the other hand, the lack of datasets still persists in a scarce domain such as industry or medical field due to the privacy issue or high annotation costs. Applying transfer learning, domain adaptation for instance, is one way to bridge the extreme domain gap. However, it is quite not common to assume there are overlapping classes between source, daily life, and target, industry or medical, domain. Therefore, few-shot learning technique necessitates to infer a novel class in target domain. This emerges cross-domain few-shot learning. We call it as CD-FSL. There are two remaining issues when applying existing CD-FSL approaches to egocentric action recognition: domain adaptability and inference cost. Solely relying on visual information is susceptible when performing on the target domain despite the domain adaptation technique, especially in egocentric scenario, where videos are often captured in a different textured environment. Moreover, utilizing multiple modalities, for example, optical flow, hand poses, is unexplored in CD-FSL setting while these modalities have proven to be effective for domain generalization in egocentric vision. In addition, although processing densely sampled frames with temporal operation requires a heavy computational cost, none of the previous work have considered the inference cost, both theoretical computational cost and inference speed. The ultimate goal in egocentric scenario is applying to resource-limited edge devices such as smart glasses. Thus, reducing the inference cost is essential for egocentric action recognition. In this work, we study cross-domain few-shot learning for egocentric action recognition using multimodal input and unlabeled target data. The figure shows our problem setup. During meta-training, we can utilize labeled source data and unlabeled target data for all modalities. In this example, RGB, optical flow and hand poses are used during meta-training. During meta-testing, only RGB modality is available, which is compatible with the previous CD-FSL setups. To address the multifaceted limitations, we propose MM-CDFSL, a novel CD-FSL approach utilizing multimodal input and unlabeled target data to enhance the adaptability to the target domain. There are two meta-training and two meta-testing stages. In the pre-training stage, domain-adapted and class-discriminative features are obtained using labeled source and unlabeled target data. Utilizing video made for reconstructing source and target inputs, our model aims to capture discriminative and shared representations between source and target domains. This pre-training process is applied independently for all input modalities. Subsequently, we perform multimodal feature distillation on the unlabeled target dataset to transfer knowledge from the teacher models trained on source and target domains for multiple modalities to the student RGB encoder. Since the teacher networks are trained on both source and target data, leveraging only unlabeled target data during multimodal distillation helps improve the adaptability of the student network to the target domain. To address the challenge of computational efficiency, we propose an ensemble masked inference, which reduces the number of input tokens by randomly masking tokens from the input data and then ensembling multiple classification results estimated from these inputs. We aim to simultaneously achieve strong adaptability to the target domain where the shift between the source and target domain is significant while improving the runtime and computational cost during the inference. In summary, our contributions are as follows. We propose a novel, challenging, but practical problem: cross-domain few-shot learning with multimodal input and unlabeled target data in egocentric scenarios. We propose MM-CDFSL, a novel approach for the CD-FSL for egocentric action recognition task that utilizes a domain-adapted and class-discriminative pre-training and multimodal feature distillation. Furthermore, we propose ensemble masked inference to reduce the computational cost. We simultaneously achieve state-of-the-art performance in terms of the accuracy and inference speed on multiple egocentric action recognition benchmarks with the CD-FSL settings. Specifically, our method outperforms the prior state-of-the-art in accuracy by an average of 6.12 and 6.10 points for one-shot and five-shot settings, while our approach is 2.2x faster than the previous approaches.